As AI researchers, we constantly want to test out and benchmark the newest massive models. But due to the limited VRAM and standard consumer GPUs, we're usually stuck on relying on smaller models. That's why we built Kiwi. Kiwi is a decentralized serverless LLM gateway that knits together idle consumer GPUs into a unified AI cluster capable of running those massive models. For example, running Llama 3.23 billion normally requires about 8 gigabytes of VRAM. However, my teammates and I only have maximum of 4 gigabytes on our devices, leaving us stuck. I'm running local worker nodes while teammates host more nodes hundreds of miles away. None of these individual nodes hold the entire model. Instead, the gateway orchestrates a pipeline, splitting the Llama 3.2 model end to end across four of our 4 gigabyte devices. It intelligently routes the request, optimizing for VRAM and latency. As you can see, the text streams seamlessly, allowing us to run a model that physically shouldn't fit on our hardware. Here on my screen is a live swarm. I have the gateway and the two worker nodes running locally, while my teammates are hosting 4 more nodes, hundreds of miles away. Because we have distributed 3 complete copies of the model across the network, our minimum redundancy is set currently to 3. In this setup, none of the individual nodes are hosting an entire model. Instead, they only hold a subset of the layers. When a prompt comes in, the gateway orchestrates the pipeline. It calculates exactly which nodes a request should flow through, continuously optimizing for available VRAM, layer completion, minimizing the number of nodes involved, and keeping the latency as low as possible. Now we'll showcase what happens when a node disconnects. Over a consumer network, this happens all the time. I'm going to simulate this by manually killing off an active node mid-generation. Notice that rather than your entire request failing, Kiwi instantly reacts, it recomputes a path for the request, and the new nodes rapidly recompute the Kiwi cache. From the user's perspective, the rerouting is completely seamless and the text just keeps flowing. To make this fast over the standard internet, we implemented heavy optimizations. We use a ZSTD compression and smoothquant style dual skill int-8 quantization to shrink our payloads, alongside a true P2P networking layer to optimize data transfer. As you can see in our benchmarks, this distributed approach vastly outperforms attempting to run the same massive model locally when it doesn't fit into a single GPU and it's forced into agonizingly slow CPU offloading. Finally, here's how we built this. We used ChatGPT with GPT 5.5 to research existing solutions and generate our initial architecture. Then we used Codex to create a proof of concept. Once we exhausted our weekly Codex quota, we switched to anti-gravity using the GPT OS's 120 billion model to build the remaining features and debug a complex networking logic. Thank you for watching.